Today we will be looking at knife base classifier. Knife base is a simple learning algorithm that utilizes Bayes' rule together with a strong assumption that the attributes are conditionally independent. Given the class, coupled with its computational efficiency and many other desirable features, this leads to knife base being widely applied in practice. The bookish definition looks very overwhelming, so let us learn with a practical demonstration. To begin with our text classification, let us introduce ourselves with the problem statement at hand. Our task today will be to classify tweets that that are disaster related tweets or not. Twitter has become an important communication channel in times of emergency. The usage of smartphones enables people to announce an emergency they're observing in real time. Because of this, more agencies are interested in programmatically monitoring Twitter tweets, etc., from disaster relief organization and news agencies. But it's not always clear whether a person's words are actually announcing a disaster. To begin with our task, we first import the necessary libraries such as pandas, numpy, matplotlib, and so on. A very important library we'll be using today is the word cloud library. The word cloud library would help us form a word cloud of the important keywords and decide whether a particular tweet falls under the category of disaster related tweets or not. We upload the train dataset and the test dataset onto the system. Then we read the dataset. Notice how the keywords column has null values and even the location value has null values. The location from where the tweet has been made may not be that important at times because a person may sit at one end of the world and tweet about something that is happening in a totally different location. In the text, the disaster related words such as earthquake in the first text, forest fire in the second text are considered as disaster related tweets, and such tweets are given a target of 1, and non disaster tweets have a target of 0. Only the Because the keyword column and the location column have null values, they are ignored, and only the text column and the target column are extracted. We then split the train dataset into train and validation dataset. We then extract the tokens from our text data. Revision of what a lemmatizer is. For grammatical reasons, documents are going to be used in different forms of a word, and there are families of derivationally related words with similar meaning. such as democracy, democratic, democratization, etc. In many situations, it seems as if it would be useful for search for one of these words to return documents that contains another words in a set. In simple words, means that by searching a half of that word, the rest of the word can appear in search engines. Now, if we search for the word D O DEMOC, the words democracy, democratic, democratization come as suggestions. Hence, it helps us give shorter vocabulary if we use a root meaning or the words of which these form a part. Lemmatization and stemming are two techniques to get the root word, but stemming is crude and usually returns words with no meanings. This has been seen in the previous video lectures where the root word formed through stemming do not exist sometimes, but lemmatization and hence by lemmatization is a better approach by verifying if the words exist in the dictionary. In uh, in our work, we will use a very short list of stop words that are generally the most common words in language and that do not provide useful information about the context, so we can remove them. We then convert the text documents, that is our tweets in this work, to matrix of tokens and word counts. If we do not have a prior dictionary and we do not use an analyzer that does some kind of feature selection, then the number of features will be equal to the vocabulary size found by analyzing the data. Hence, it is important to have a dictionary list or a list of stop words which can be removed from the context of the dataset. We use lemmatization and create the stop words. A tokenizer is very simple. It applies lowercase to the text, removes very short words, lemmatizes the words, and finally removes the stop words. As we have discussed, we're not coding an expert parser for tweets. It's a simple task of detecting or rather classifying whether certain tweets belong to the section of disaster tweets or not. We have the function myTokenizer here where we convert the text into lowercase, split them into strings, remove the shorter words if they're not useful, put the words into its base form, that is its root word, and remove stop words. First, we create our vocabulary, the list of words or tokens we are expecting in our sentences. We tokenize all the tweets, save all the tokens, and include them in the vocabulary. A vocabulary is based on the train set. It is supposed that the test set is just for testing our model, and we do not know anything about it. But there would be probably few new tokens in our test set or future test text. This is necessary because it is necessary so that the system can detect undetected situation or unexpected situations in the future. We create a vocabulary by tokenizing every document, collect the tokens, and extract the vocabulary. We extract we extract the tokens in the document, store the tokens into two lists. We then create a dictionary of vocabulary to convert strings and tokens to integers and add tokens to a unknown to the dictionary, which means that if a particular token is not come across yet, it will be added to the dictionary. If it's already present within the dictionary, it will be ignored. We then create the term document matrix of our train and test data. We will create our own version of the term document matrix. This is basically for two main reasons: to understand what sklearn is doing underneath the hood, and to create something that will work with fast AI text list. To create our own term document matrix, we will use counters and sparse matrices. To create the term document matrix, we won't be using any package. We'll be just passing the text and building our matrix. Yeah, this is a simple function to create the matrix. It's pretty easy to understand once you have a look at it. For debugging purposes, we will return the values and the indices and the pointer where it points. We will generate the text document matrix and get term document matrix. The test dataset, we need to check if the token is in the vocabulary list. If not, we replace it by the special tokens which are kept for the unknown words. So we come to naive Bayes. Naive Bayes classifier is a family of classifiers that are based on the popular Bayes probability theorem, which are known for creating simple yet well-performing models, especially in the field of document classification and disease prediction. The probabilistic model of naive Bayes classifier is based on Bayes' theorem, and the adjective naive comes from the assumption that the features in the dataset are mutually independent. In practice, the independence assumption is often violated, but naive Bayes classifier still tends to perform very well under this unrealistic assumption, especially for small sample sizes. Naive Bayes classifier can outperform the more or most powerful alternatives. Actually, most powerful would not be particularly right because there are other algorithms which perform better than naive Bayes, but it performs better than more or less the closest algorithms. Bayes' rule can be written down in simple words as follows: the posterior probability, which is the conditional probability unknown of the unknown character, and the prior probability by the evidence. In the context of pattern classification, the prior probabilities are also called as class priors, which describe the general probability of encountering a particular class. In our case, the priors could be formulated as fake, that is unknown character, the fake or unknown character, the probability that any new message is a fake message, or a P of a real, probability a real, which means that unknown character is not a fake message. In context of classification, we determine the probability of a fake as the ratio of the fake messages in training data to all the messages present in the training data. For numerically stability purpose, we are going to look at the log probability by taking the log of each side. Now we're dealing with additions of log probabilities instead of multiplying many probabilities together. Since log has really nice properties, that is monotonicity being the key one, we can still take the highest score to our prediction. That is, we don't have to undo the log. We define the log count as R for each word f. Then we have the log function, where we define the ratio of the features in positive documents and the ratio of the features in the negative documents. The ratio of the feature f in positive documents is the number of times a positive document has a feature divided by the number of positive documents. We then have the function to find the term document matrix and see if that is the target label. We then sum the array values. In order to avoid the problem of zero probabilities or division by zero, an additional smoothing term can be added to the base model. The most common variation or variants of additive smoothing are the so-called Lidstone smoothing, that is giving the alpha values of less than 1, and Laplace smoothing, that is giving the value of 1 to alpha. So we add 1 to the numerator as well as the denominator, hence avoiding the possibility of zero probability or division by zero. In the next cell, we will be observing the vocabulary in the most positive and negative tweets. We have the list of vocabulary here: derailment, investigator, debris, Hiroshima, migrant, northern, legionnaire, MH370, severe, Malaysia. These are the biggest vocabularies, biggest ones. And for the smallest ones, we have mayhem, bag, cat, career, ruin, Disney, eBay, LMAO, character, crust. Notice how in these two lists, the MH370 and LMAO, and even things like eBay, Disney, etc., do not necessarily exist in the English dictionary. These are proper nouns and short forms, but in Twitter, not everybody uses dictionary words, right? Some people may use SMS language or short forms. And MH370, Disney, eBay being proper nouns. MH370 was the name of a Malaysian airlines which went missing. Now applying naive Bayes, we find the mean of the train dataset for the disaster tweets, hence giving the white rain value if it's equal to 1, and we find the mean for the non-disaster rain sets. We predict the model of the term, and we find the mean of the predicted model in the test dataset, which accounts to 76%. Now evaluating the model, we will discuss evaluation of the model in the next video.